We were approached by orthopedic surgeons, our partners in Canberra Hospital, and they came to us with a question. If I have a patient's digital anatomy, so the patient's CT scan essentially, so is there a way that we could quickly design a bone plate for the patient and to actually fabricate the plate?
So the problem we were trying to solve was when we have complex fractures that we fix, we use plates and screws to fix them, and they're designed for the average person, which means that they fit almost nobody, and that slows us down. We have to bend plates, we have to adjust what we do, and a better solution would be to develop a custom plate which is contoured to an individual patient, and that requires significant planning and manufacturing capabilities to achieve that.
So one of the projects that I lead within the M3D training center deals with visualization and modeling and manipulation of the digital materials. So starting from X-ray scanning of a structure, a material, you can very easily in your computer do all sorts of processing, optimization, modeling, etc. And at the last stage, you can actually fabricate using 3D printing.
That expertise, funnily enough, had a particular skill set that was transferable to what we were trying to achieve, and so that enabled us to work on a project where we could use some of their technical expertise and apply it to the problem we were having in orthopedic surgery, which was to try and get plates to fit well to individual patients.
We decided that the best way to do it, instead of talking all the time, to do a process from start to end for a patient. So we received a patient's CT scan with a fairly severe femur trauma that was there for decades. Never said properly. He had an injury when he was a teenager, and he went to the hospital apparently, and they told him, look, just go home and rest until it's fixed. But the trauma was too severe to be able to design a plate that could be optimized for the patient's bone anatomy. But we also had access to the CT scan of the healthy side of the femur. So what we did, we used that as a guide. So we used the mirror symmetry of the healthy side to design a plate that could roughly follow the contour or the shape of the patient's femur. And then we did tweaking specifically for the parts that were traumatized over many, many decades.
The day when we first implemented this, we had a fracture that required very careful fixation, and we had a plate ready to go which was contoured specifically for that patient, and the surgery itself went smoothly. These are not small operations, they take hours, but having had the planning that went into that surgery and having had a plate that was specific for that patient enabled the whole process to go more smoothly than what it normally would.
And it didn't require any manipulation. And the comment I received from the orthopedic surgeon was that this is actually the first time that the orthopedic surgeon didn't have to go to the toolbox for the bending and twisting and forming of the plate so it would fit. Every minute spent in the surgery with the patient being under full anesthetic adds to the cost, to the recovery time, and also potential infection, right? So if you reduce this time by even minutes, that is a game changer. The patient will save money, the patient will recover faster, there is a less chance of having a second refixing surgery. So everyone is a winner.
It's only a matter of time before we develop custom plates for a lot more patients, in particular in complex environments.
Everyone should have access to customized plates. I was talking to Tom, the surgeon. He said many of the surgeries are redone. This is incredible, because it's primarily because the plates are not a good fit. Currently, there are very limited options available to the patients for when it comes to bone plates. It takes anything between 6 months to a year to do a plate customization for a bone injury. And it's often upwards of $50,000, right? So, but what we did here was fast, really cheap, and from the moment we received the patient's CT scan from the hospital to the point that we had a customized plate based on the anatomy of that specific patient, the whole process was around 10 days. That was the first trial, and we think there is a lot of room for improvement. So we have just started a startup company to basically develop the process further and streamline it so we can perform the entire process within that 4 or 5 days required time frame by the medical community.
To be involved in helping step forward to that next level, those better treatments, the new frontier of using technology in surgery is always really exciting.
We are physicists, we write codes, we do pretty abstract things, and knowing that some of those things that we developed over decades now can find their ways into making a real difference to the real world, but to also people who are in need of a technology that can make their lives better. It feels pretty good, you know, and it's a team effort. So I might be the face of it, but my team basically did most of it.
So the ANU team brought great intellect, expertise. They were flexible, they were likable, they communicate well, and you add all that together and it forms the X factor that makes teams work and that enables you to develop new technologies. It
feels good at many levels that this teamwork that we have within this M3D training center allows us to do so many interesting things that can find their way into real-world applications, including biomedical engineering.